Okay, so we are going to pick up where we left off, which is problem 88. So then 88 says Carlo got a pet snake at his birthday present. On his birthday, the baby snake was just 26 centimeters long. He has been watching it closely and has noticed that it has been growing 2 centimeters each week. Create multiple representations, table, graph, and equation of the function for which the inputs are weeks since Carlo's birthday and the outputs are the length of the snake. So when we work this way, our x and our y, or our inputs and our outputs, they said was weeks and length of snake. So when Carlos bought the snake, so at time 0 when he got it, it was 26 centimeters long. And then he said he kept a close eye on it and noticed it's 2 centimeters each week. So after week 1, it's grown 2 centimeters, so add 2. And keep doing that just so you get a couple of numbers, so that we can make a graph off of it. So it doesn't have to be perfect. So then number 88, we're going to make the equation, if you would like. So it started with 26, and it had a slope or a change of plus 2 for every 1 week. So our slope was 2 over 1, or 2x, plus 26. So however you want to write that. And then the graph. We don't have to make a complete graph, so it's just a quick representation of the information. So I'm just going to go 10, 20, 30. So then I'm going to start at 26, and then it's just going up 2 over 1. It does not have to be perfect, but the idea is that it's starting here and going up in a positive direction. It doesn't go negative. There's no negative time. And then it can't go any further down here because it's not going to, we're not talking about it losing height or dying or anything like that. So we're just going to leave it just like that. So then part B, it says if the snake continues to grow at the same rate, when will it be 1 meter, which it says is 100 centimeters long? How can you see this in each of the representations? So with the equation, that's going to be my quickest way to figure this guy out, unless you have patience, you want to sit there and scroll through the table, which we'll talk about. So it wants to know when will it be 100 centimeters long. So 100 centimeters was the length of the snake, which is your output. So it wants to know when will this number be 100. So if we just plug in 100 to figure out the input or the amount of weeks and then solve. So subtract 26 from both sides and divide both sides by 2. So you have an answer of 37 weeks. You could have typed the equation into the graphing calculator and gone into the table. You also could have traced and done a couple different things, but the goal is to get to the 37 weeks here. And that was it for 88. So in the next one for 89, what value of y allows you to find the x-intercept? For each of the equations below, find where the graph intersects the x-axis and write each answer as an ordered pair. So if we are looking for the x-intercept, that means we're looking for the value of x when y equals 0. So every single time if it's an x-intercept, the y value is going to be 0. So that's how I'm going to use these to solve. So for part A, it says y equals 3x plus 6. I'm trying to figure out the x-intercept, and that's when y gives me 0. So plug in 0, and then I'm just going to solve. So subtract 6 from both sides, and then divide both sides by 3. And then it wants us to, it says in the directions to write each answer as an ordered pair, so your intersection here is -2, 0. Okay, so there's my answer for part A. So in part B, same directions, but different problem now. So it's x equals 5y minus 10. Again, same goal, looking for the x-intercept, so that's when y equals 0. Now, this one, all of my numbers are on the same side and my variables over here, so I can just type this in the calculator, or 5 times 0 is 0. 0 take away 10 is -10. And again, the directions asked for the ordered pair, so -10, 0. So it's just kind of the same thing over and over and over again. So then we're at 89, part C. So y equals x squared. And again, we're looking for the x-intercept, which means our y is 0. We're figuring out the x-intercept. So, same thing. Plug in the 0 for y. To undo a square, you're going to square root both sides. And be careful when you square root, you get the plus or minus. So it's plus or minus the square root of 0 equals x. Well, the square root of 0 is just 0. And there is no positive or negative 0, so we don't have to worry about that one. So this ordered pair then is 0, 0, which means it goes through the origin. Part D, again, same thing. Plugging in a 0 for y. Solving for x. So add 4 to both sides. Divide both sides by 2. And then again, this is where you have a couple of options. If you want to keep it exact, when you square root both sides, you get plus or minus the square root of 2. That's your exact answer. Or if you wanted to type that in the calculator, which you can, you would just have to change your equal sign to an approximation symbol, and then you can write plus or minus, and it's 1.4. So again, the equal sign with the exact answer or the approximation sign with the rounded answer. Doesn't matter to us, unless it tells you, which it doesn't. So in this case, we don't care. So in part E, again, same thing. Plugging in a 0 for y. Now our x is trapped inside being squared, so now we have to square root right away. And then again, when you square root of 0 is just 0. So everything goes away. Add 5 to both sides. Oh, I got lazy on this one. Sorry, I forgot to put my answer as an ordered pair. So then we got our answer of 5, so then our ordered pair is 5, 0. So this one does have 2 answers, the positive and the negative. I apologize, I missed that. And then EF. So then F is y equals x to the third minus 13. So 0. Add 13 to both sides. So now similar to squaring and square rooting, they undo each other. So then cubing can be done with what's called a cube root. So it's a square root symbol, but now it has a little 3 in the crack right here. So that 3 here and this 3 to the third cancel. And the answer is to the third root. So it's the cubed root of 13 is x, which if you want to type that in the calculator, you can type that in to get a number. So the cubed root is a modification of the square root. So when you go into math, you see right there, it says cubed root. So you can go down to number 4, and then you just type in 13. So because it's an odd root, it doesn't have the plus or minus symbol. So you can just leave it as the cubed root of 13, 0, or I guess it's approximately 2.4, 0. So there is a key for that on the calculator, or you can leave it. It doesn't matter. So that's all of 89. Number 90, getting there. Make a complete graph of the function 2x squared plus 4x minus 6 and describe the domain and range. So complete graph means we need to label, scale, plot accurately, all of that information. So we do need our graph paper. So I'm just going to write the equation over here. So we have h of x equals 2x squared plus 4x minus 6. So then y equals 2x squared plus 4x minus 6. So it's a quadratic, so it should be a parabola, so it looks good. We got our nice U-shaped, and it's going up. So second table, I'm going to let that help me plot my points so I do it accurately. So 0, negative 6. So I'm going to go up by ones again, so I have negative 1. So I'm going to go up by ones every way. So my first one is 0, negative 6. It's right there. And then has 1, 0, 2, 10. Okay, that's off my graph paper. So I'm going to go the other way because I'm not going to go all the way up to 24. So let's do negative 1, negative 8. And then negative 2, negative 6, and then negative 3, 0, and 4, 10. I can move this out of my way, get my nice U shape. Arrows on both sides, it continues on in both directions. So now your key points again are your intercepts. So this guy is 1, 0, then we got negative 3, 0, and that was 0, negative 6. Now a key point for a parabola is that vertex, so in this case it's this bottom point, so that's negative 1, negative 8. So that's another key point we can label. Everything else in the middle is just helping us make our shape accurately, so those don't need to be labeled. So that's labeled completely. And then now it says describe the domain and range, so I'm going to do what I did last time, so I'm going to do my domain and range. But my domain is how far left and right the graph goes, and this is a parabola that continues like this in a U shape. So you have two options for this. You can write all reals, which means everything left and everything right, or the mathematical way of writing that is from negative infinity all the way through positive infinity. So think of this combination as like through. So negative infinity through infinity and everything in between. So, you know, infinity and beyond. Whereas then the range, again, is going up and down. So if I started down here and I kept moving, I won't touch that parabola till right here. And then I touch everywhere else. But the bottommost part of my parabola is right there, and the range is looking at the output. So my range is everything above negative 8. So that's number 90. So next one is 91. So it says solve each equation for the indicated variable. So it says y equals mx plus b for x. So when we're solving this, it says for x, so we need to leave x right there and move everything away from x by undoing. So I'm going to subtract my b from both sides. It seems weird, but when I subtract b from both sides, over here is a y. Those are two different letters, so they're not like. So keep them separate, so just minus the b from it. And now I have an m attached, which still means it's a multiplication bond, so break the bond with division. Again, it seems weird because it's a letter, but they follow the same principles here. So my answer is y minus b all over m equals x, and that's the answer. Seems weird, but it's undoing just like numbers. It's just since there are no like terms, all the letters get their different spots. So now we have area equals pi r squared. If you remember from geometry, that's area of a circle. Doesn't actually matter, but just fun fact. And it wants us to solve for r. So r is the variable that we are trying to get by itself. So what you're going to do is undo the order of operations, but remember when you undo, you go backwards. So we're going to move the multiplication, which is pi first. And you don't have to type in 3.14, just leave pi. So it's area over pi equals r squared. We're not done because it said solve for r, and we have r squared. So we're going to square root both sides. And then don't forget that when you square root anything, a plus or minus symbol pops up. And r is now by itself, so we are now done. Seems funky, feels weird, but that's how it needs to go. Let's see if I can fit. So in part C is volume equals length times height times width. So we're doing area of a prism here, in case anyone remembers their geometry, which is, we're looking for W. So we're looking for this guy right here. Now both of these, all three of these have the same bond. It's a multiplication bond and another multiplication bond. So these are both being held with multiplication. You can undo them at the same time because it's the same thing. So we can divide right off the gate by L and H, and that will get rid of both of them at the same time. So volume over length times height will give you width. And that one's done. Last one for this one is part D. Oh man. 2x plus 1 over y equals 3. So when you're doing this one, you have to be very careful because now you have, you have variables in the denominator. So we're going to work on, it says for y. So this y is all the way down in the denominator, so it is going to make it tricky later, but for right now, let's just try and get it by itself. So subtract 2x from both sides. But now, to get the y out of the denominator, you're actually going to multiply both sides by y. So when you multiply both sides by y, it's now gone on this side. We still have 1 equals. I'm not going to distribute it. Just leave it on the outside like that. Because remember, our goal is to get y by itself. So let's keep it on the outside by itself. This entire expression is held together with parentheses. So you can divide it. You can divide the whole thing to get the y by itself. So your final answer for this one is y equals 1 over, and then in parentheses you have your 3 minus 2x. That one I'd say is the trickiest, because you had to get the y or your variable out of a denominator. So you had to get rid of it just to bring it back.